Let's solve this given homogeneous differential equation stated here. Take note that the degree or the order of this differential equation is fourth order because we have here this notation. But it's also important to know that our dependent variable here is no longer y. The dependent variable here is x. That's what you can see here. And your independent variable is now t. Hence, we are going to solve x in terms of t. We will no longer be using y in the process. We'll talk about that as we end this video later. This is already given to have distinct and real roots pertaining to its auxiliary equation, because there are different ways to express our solution for 4 different cases. This is the first one, when the roots are all real and distinct, meaning they are different from one another. There are also some different process if our roots are all real, but some of them repeats or there are multiplicity of any of the roots. Another case will happen if our roots are imaginary, and the last one if there are also imaginary roots with multiplicity or repeated imaginary roots. So this disclaimer, we are given that they are already distinct and real, but of course for some instances later on we are not sure. It's still good for us to verify. So the first step here is to come up with our equation using the differential operator d. So we have here d, the power, you will have your f of d again of x, because x is your dependent variable, equal to 0. That's equal. Let me rewrite this one. Equal to 0. So our equation using differential operator would be d to the power of 4 minus 10 d cubed plus 35 d squared minus 50 d plus 24, all of them multiplied to x equal to 0. After then, we need to come up with its equivalent auxiliary equation f of m. Hence, our equation now would be m to the power of 4 minus 10 m cubed plus 35 m squared minus 50m plus 24 equal to 0. Using this given auxiliary equation, we're going to solve for the roots. And since we have here m to the power of 4, we expect to have 4 roots. And as given, they should be real and distinct. But if we're not sure, there are 4 roots of this given equation now. Now, there are a lot of processes, one of which is what we call as the rational root or rational zero theorem, which will use the P over Q coefficients. P are the factors of your constant 24. So you will have 1, 2, 3, 4, 6, 8. Also have 12, right? 12 times 2, 6 times 4, 2 times 8, 1, and 24, including the negative plus minus, plus minus, plus minus, plus minus, plus minus, plus minus, plus minus. And then your Q would be the factors of your leading coefficients. You have plus minus 1. However, there are a lot of values you can try because there are 8 possible. Then at the times 2, because we have positive and negative, there are 16 trials. For our P over Q to try on to this, which will make it equal to 0. So you would actually use a lot of time. Hence, there are also some instances where your rational root 0 or rational root or rational zero theorem is no longer easier to be used. Hence, we're going to go back to our intuition. Try to think the first value that you can try and substitute it here will result this side equal to 0. Of course, we could start with the integers. The smallest integer is 1. And then you will have 2. You could also try the negative, negative 1 and negative 2. But when we see here, if we're going to try m equal to 1, your first term would be 1 to the power of 4 minus 10 times 1 cubed plus 35 times 1 minus 50 times 1 plus 24. Is it equal to 0? Let's check. 1 minus 10 plus 35 minus 50 plus 24. This is negative 60, 36, positive 60. Yes, it's equal to 0. This shows that m equal to 1 is our first root by trial and error or by intuition. Hence, your first factor You don't need to do this because we're looking for roots, but I'm just going to present the factors to emphasize it later on with the rest of the factors or roots. Your first factor is m minus 1 equal to 0. Take note of that. These two will be very important. Now that we are sure that that's our first root, we can now use here syntactic division to make this a cubic function instead of the quartic function. So you have 1 minus 10, 35, minus 50, 24, and then your coefficient here is 1. This also checking because it could verify that 1 is really a root. So trying that, 1 times 1 is 1. That's minus 9 when you add them up. Negative 9 times 1 is negative 9. When you subtract, you will have 26. 26 times 1 is 26. You'll have minus 24. You have minus 24, 0. Once you reach a remainder of 0, this shows that this is really correct as your first root and your first factor of m minus 1 is really correct. So going further, what you have now is m cubed minus 9m squared plus 26m minus 24 equal to 0. Still, our coefficient here is 24, so you have 24 earlier. We'll also be trying the same sets of possibilities for you under rational root or rational zero theorem. So let's just continue your intuition. If you're going to try another one, even if it's decided already distinct and real, just for the purpose of discussion, you will have 1 cubed minus 9 times 1 plus 26 times 1 minus 24. Let's check if it's equal to 0. 1 minus 9 plus 26 minus 24. This is 27. This is minus 33. Of course, it's not equal to 0. Hence, it's only the root of 1 is only with 1 it's no longer, or 1 is not duplicated or it's not repeated. So it's incorrect to assume that the second root is 1. So with that, of course, we use trial and error. Let's use another integer. You could also try negative 1, but let me try here 2. So you have 2 cubed is 8 minus 9 times 2 squared, which is 4, plus 26 times 2 minus 24. Let's check if it's equal to 0. 8 minus 36 plus 52 minus 24. Is it equal to 0? This is 60 minus 60. Yes, it's equal to 0. Hence, this is your second root, and that's correct. Okay? That's also another trial you can use here. I'm realizing this to continue with the process, as you are now sure to this to be our second root, and your second factor is m minus 2. Okay? That's your second factor. We'll be using that, another syntactic division. 1 minus 9, 26 minus 24. You will have here positive 2. So you have 1 times 2 is 2. Add them up, negative 7 times 2 is negative 14. You add them up, that's actually positive 12. Minus times 2 is 24. Yes. Using this, that's already a verification that that is a correct root. So the final form now, or the next form rather, is m squared minus 7m plus 12 equal to 0. Here, you don't need to use intuition. You can simply use here the process in solving the roots of a quadratic function, because this is a quadratic function now. Or, sorry, quadratic equation. You can use the quadratic formula or simply use the factoring. AC is 1 times 12. That's 12. Factors of 12 when added will result to our middle term, negative 7. So you have factors 12 and 1, 6 and 2, including the negatives. But the factors here are actually minus 3 and minus 4. Because negative 3 times negative 4 is 12, positive 12. Negative 3 plus negative 4, that's negative 7. That's our middle term here. Hence, the factors here are m minus 3 and m minus 4 equal to 0. With all of these 4 factors, our auxiliary equation earlier will be broken down into these factors. Your first factor is m minus 1. Okay? M minus 1 times m minus 2 times m minus 3 times m minus 4 equal to 0. Of course, we have already shown the 2 factors, but just for the purpose of discussion, let's just continue here using a zero factor or zero product property. m minus 1 equal to 0, the first root is 1. M minus 2 equal to 0, the second root is 2. The third root is when m minus 3 is equal to 0, so it's actually a 3. And finally, m minus 4 equal to 0, the fourth root is now 4. Clearly, the roots are distinct and all real. So this is already satisfied as claimed earlier. Now that we are sure that they are distinct and real, we have a specific solution for situations or homogeneous differential equations where the roots of the auxiliary equation are all distinct and real. We have this process. Your dependent variable earlier was not y, it's actually x. So in general solution, it should be y equal to c sub 1 m 1x. But since y is no longer the what they call this one, the dependent, and x is not the independent, it will be transformed in this manner. Please take note of this. This is where some of us will get incorrect answers. It's just x as our dependent variable here equal to c sub 1 e to the power of the first root and then t, your independent variable, plus c sub 2 e to the power of m2t plus dot 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 plus your nth constant paired with e to the power of mn, your nth root times t. Since we have 4 roots here, so we expect to have 4 terms. And the solution here is in this manner. C sub 1, any variable now, or any constant rather, e to the power of your first root, 1t, plus c sub 2, e to the power of your second root, 2t, plus c sub 3, your third constant, e to the power of your third root, 3t. Surprisingly, our roots are arranged, but doesn't necessarily to be that way. Our fourth term is c sub 4 e to the power of 4t. Again, it doesn't necessarily work that way because we are just lucky to start with m minus 1 as first factor, m minus 2 is second. Of course, in our 2, we can always interchange negative 4 and negative 3 here. So if they are interchanged, the roots will also be interchanged. So it doesn't follow a certain order. So if you're going to write it this manner, or you will have 4 and 3 here, they are just of the same answer, regardless of whether what's the location of your c sub 3 and c sub 4 constants, because they are just arbitrary constants. And here is the solution of our given homogeneous differential equation. Okay, so we had all of this process to solve for this item. Thank you very much for watching.